Hello. Uh, Tonight I'm going to be showing off my custom C++ sprite render component for my game engine. I made this to change up how the my class's game engine rendering systems work. Previously, um, we would get a function call. We would give the user a function call where they can draw text or images to the screen. This was saved as a request and later processed by the renderer. We are not able, uh, because we're getting these from Lua, and Lua is also asking, allows the user to change the scale of the image. We have to take all the requests on the off chance they might be same. And aside from having the bridge between Lua and C++ and having a large number that will eventually possibly get sorted in the rendering pipeline. Um, it also forced us to render images in the world space, images in the UI space, text, and then any pixel colors in that specific order, meaning that we can never have text in the world space, and there was very limited control of what we could do with that. I wanted to have a bit more control with this, so I changed my rendering framework to allow the component to access the renderer data, and the renderer stores all the components inside vectors. All these vectors are stored into objects called layers, and layers belong either to a folder or a map of world layers and a map of UI layers. What we in my rendering framework, um, it collects all the requests after all the Lewis RAM, so we know exactly what the screen size is going to be. And we also actually we have the ability to tell a render or tell a layer not to sort itself if we believe that is what we want. And when the rendering actually goes through, it's going to iterate through all the sprite renders, ask itself, um, is the sprite render alive? And is the sprite renderer, would it be on screen? Then it's going to load, if both of those cases are true, it will load up all the required data to render that image to the screen, and then save it as a draw request at that point. Meaning that we're going to be saving a much smaller number of requests than we would have originally with very large scenes. After all those requests are collected, the render asks if this layer should be sorted. It sorts it if it wants to. Otherwise, it moves on to the next layer. And when all the world layers are done, the UI layers are rendered as well. During the Lua update, though, um, the render can have effectively any of its data changed, and all the user needs to do is tell the renderer, hey, update your position, update your rotation, and the render will privately tell the renderer, hey, I am this specific render, and the background information or the background renderer will update it with the changes that it wants. Um, this led to a really nice performance increase. It is more noticeable with much larger map size. Part of this is my original system did not actually remove any images on screen and that are not visible. And that also slowed things down. But if I go to the component right now, and we're going to start off with the class solution to show off the difference in performance. The rendering of this is uncapped, meaning that it's going to try to render the images as fast as possible. Um, and it should take about 25 seconds. this is almost real time despite it being uncapped, which shows that it works, or the class solution does work. However, I did not. It felt like it could be faster. Um, it just ran for 18 seconds. A side tangent about this: it's sometimes varies by a few seconds for both solutions. But if I go to here and swap it back to my solution, just a heads up, I have a lot more stuff going on in my scene, which should in theory slow it down. Um, but that's just a another thing to keep in mind. Um, Effectively rendering at double speed. We have the text render gain updated with my text render. All the sprites being rendered in mine, and it ended up being about 10.4 seconds. Um, this is pretty nice. I'm going to take a moment to actually walk through the render on my own. Uh, but so if I go here, I'm just going to pull this up real quick. I need to find the okay. Let's see. User input, and I can delete that. Okay, so now it's deleted. I go back to here and run this. Now we're I in control of the render. Um these image the ball and the cubes right now are just changing their color. Position, rotation, getting updated. Um if you look at time, this should be or yeah, it should already be running about 2 times speed. Um but if I go over here, um, we change the image to some text that tells us we want. Um, the actual component does not just has some mild logic to say if this should be text, it renders text based on what we want. If it should be a picture, it renders it separately. Um, if we look on the side, I have all the I'm testing all the functions for collecting data. Um, if I run through the victory thing, it will get updated. But first off, let's just change the layer of what this is on. Actually, no, let's start with the scale. Um, Now the text is much larger. Text can even have its color changed as well. Um, but let's say, for example, we um, wanted this text or world object to be rendered on a layer behind. Um, it's still in the world, but now we can have text in the background, which was not something we could do previously. I'm going to jump up here for a second. This is about in the world where should be at the 0, 0 mark, where UI is just considered to be at. If I change, if we look down here for the last set of renders, it does not think it's UI. But if I go ahead and change it, it's now being rendered in the screen space, assuming things UI. If I move off screen, it's going to disappear. But now it thinks it is UI. Uh, let's see. And if I jump back here, it comes back. Um, let's set this back to a UI or a world space. Um, Now a couple other things: position, rotations, gain updated. We can get the scale and where the center of the image should be. Let's see. This should be changing the center right now. Um, and it tells us what value is currently stored in the calculations. Now it's back to the original, and now it's on the other side. We can see those two values right here. Now it's back in the center and back move. Um, let's see. No, let's see. Now I changed the scale just back to 1 1. You can see that the value is being collected. If I, let's say, bring the scale back up, and let's just say I want to change the sorting layer, this shouldn't be actually seen, um, or won't be visually noticeable, just due to how this is set up right now. But now the layer is 5. Um, Now we have the layer is 1, and it's uh, just like you can get the values for what's being stored. You can change what layer and what type of a layer it is. You can render text in any format you want now. You can render text wherever you want now. And it's overall faster than what the previous solution was. Um, yeah. And let's see, I think I showed this, but you can also get the color values too. Um, but yeah, I'm gonna pause the video for a second and look to see if there's anything else I need. Just a before we go, here's a list of taking the my functions and the data of the component and funneling it into Lua so we can access it. Um, if like we take a look at the templates or the Lua functions, if we wanted to set some default values for like color or text and stuff, these would be the keys that we would use to access the data. After the function runs its on-start updates, these data keys are no longer guaranteed to be valid. At that point, you need to use these functions if you want access and change data. Um, and you would just have to use this code. I actually can go ahead and scroll down to show off the inputs you need. Um, so for most of this, um, it just passes the component stores an ID for its key for passing along data. Um, but if it wanted to get some data, it would go ask the render for it. If it wanted to uh, let's see, like that debug, but if we want to send some data back or just let's see, if we want to get the data, if we want to change the data, we would just use these different functions and take the different variables and pass them in Lua. Uh, Very nice interface. User shouldn't have to like consider what who should be able to just keep track of the component on their end or keep track of what they think the component is, yet all the data is actually stored in the render handler. Um, and yeah, it's just a very basic interface. Um, I hope you guys like my demonstration and all the cool stuff that you can do with uh, the component itself and all the performance boosts and just cool new features. Have a nice night.